Let us move on towards our first operation, and that is the insertion operation, which in terms of stack is called as push operation. So let us consider one empty stack right now. Empty stack. So this is one empty stack, right? So we will just consider it as a stack of integer numbers, and let the size of this particular stack be 4. Okay. Now, due to the property that the stack has similar type of elements in it, we are going to implement stack using the concept of array, right? Now, this is one of the array, right? But this time it is in vertical format. Why? Because the pile of plates, the pile of chairs, and the pile of bowls are always kept in vertical format instead of keeping it in horizontal format. So we should have stack also in vertical format so that it will not exploit or violate its rules. Getting? So now this is one of the array, but now it will be treated as a stack. The size of this particular stack is considered to be n is equal to 4, and the index of this particular stack array starts from the bottom side. So here it is 0th index, then we have first index, then second index, sorry I missed out, it is third index. So this is the array, stack array of size 4. Now the thing is that we need to have the top end, right? And for having the top end, we need to have one integer variable labeled as stack, which is always being initialized to -1. And where do we have -1 in this particular stack array? It is always below 0. So let us assume that this particular -1 is over here, and now because of this particular initialization, top is equal to -1, our top is pointing to this particular -1th position on the stack, right? Okay, now this push operation is already discussed, but I am just revising it. Now let us do one thing. Let us insert one element in the stack. So I need to insert, suppose for example, I need to insert 10 in my stack, right? But as this stack array starts from 0th location, the element assignment is to be done at 0th position of this stack array. But the problem is that right now my top variable is pointing to -1th position. So for this purpose, firstly I need to increment my top variable by 1 so that it will be pointing to the 0th position. Then and then only it is possible to insert the element on the 0th position, right? Firstly, let us name this particular stack array as A. You can take any of the name that you want, whichever you find is feasible for you, but take meaningful names. So here I have considered this stack array with the name as A, right? Now I want to insert this element 10 on this particular position. Top is at -1th position. So firstly what we will do, we have to increment the top by 1. So I will just write the steps over here. So increment top by 1. Now by executing this particular statement, the top gets incremented to 0th position. Now we got top on the 0th position. Now it's time to insert this 10 over here. Do one thing, instead of assigning the 10 value directly to A of top, accept the values from the user. So accept, I will just write the second step as accept element from user, and save it in one variable. Let the variable be element. So element is equal to, this time it is 10. So what we are doing, we have accepted the value from the user, let the user give the value as 10, and now this 10 is assigned to the variable element. Now I need to assign this element having the value 10 to this particular 0th position where my top is pointing. So I need to write down the statement as A of top equal to element. Now because of this particular statement, whatever value that particular element variable is having, that will be assigned to that particular location where top variable is pointing in the stack array labeled as A. So in this particular example, now 10 gets assigned to the 0th position where top is pointing. Now just assume that the user again called the push function. He needs to again push one new element in the stack, right? So again what is to be done? Top will be incremented by 1. How? Why? Because we have written that particular statement over here, increment top by 1. So this particular statement after getting executed, now my top variable points to first position. Top is now pointing to first position, right? What is the further step? Accept element from user. Now let this time the element be 20. Let this time the element be 20. And because of this particular statement, now 20 gets assigned to the position where top is pointing. Top is pointing to the first position, so 20 will be assigned or inserted on the first position. Assume that again the user called the push function. Again he wants to insert a new data or new number in the stack. So again this particular statement will be executed first. What is that? Increment top by 1. So now top will be pointing to second position. Now the top variable is pointing to second position, right? After that, accept the element from user. Now this time let the user enter the value as 30. See, you can take any of the number. 10, 20, 30 are my favorite numbers, so I am considering 10, 20, 30 in each and every example. So now let the number 30 be inserted in the stack. 30 got assigned to the variable element, and now we are assigning that particular element to A of top, where top is pointing. So right now top is pointing to the second position. This particular element having the value as 30 will be inserted on the second position, 30, right? Now again assume that again the user called the push function, which means that again he wants to insert a new element in the stack, right? Again these statements will be implemented. So firstly, increment top by 1. So now top will be pointing to the third position. Top points to the third position. Second step is accept element from the user. Let this time the user give the value as 40 and assign that particular value to the top position, right? So 40 got inserted over here. Getting? Now again one more time, let the user call push function to add a new element. But the problem is that now top gets incremented to fourth position, but the size of our array is actually 4, and we have already inserted 4 elements in the stack, which means that the stack is full. The stack is already full and still we are trying to insert the element in the stack. This particular condition when encountered is called as stack overflow. Overflow, which means that already the stack is full with its capacity. Here the capacity of the stack is of 4 elements. We can see that 4 elements are already inserted in the stack, and still if you are trying to insert the new element in the stack, then it should result in stack overflow condition. So now while pushing element in the stack, every time we need to check whether the stack is full or not. If it is full, simply print that stack overflow. If it is not, then perform these steps. Now let us write the steps one by one of the push operation. Let us see what are the steps. Firstly, you need to initialize a stack to be empty, right? So initialize stack to be empty. Getting? How to initialize this to be empty? Just take the variable top is equal to -1, right? It means that stack is empty right now. Then the next step should be check whether the stack is full or not. Check whether the stack is full or not. Second step is to check whether the stack is full or not. If it is full, which means that we cannot insert new element in the stack. If it is not full, it means that there is still some space vacant. There are still some positions vacant where we can perform the push operation. Getting? Now I will just elaborate this second step further. So if the stack is not full, then push means insert a new element at the top of the stack. Getting? If the stack is not full, then and then only you will be able to push or insert a new element in the stack. But what if the stack is full? That I will write in terms of else. else print that stack is full. Else print stack is full, which means that no further insertion is possible. Getting everyone? So these are the steps to be implemented under push operation. Clear? See, one more time we will see these particular steps. Now, going through one example, let us consider one example. Let us take the size of the stack as 3. Stack of the size as 3. Right? So, I am drawing one empty stack over here. So, top again initialized to -1. Getting? So, we are having the indices of this stack array as 0, 1, 2 and -1. And because of this particular initialization, now my top is pointing to -1th position. Getting? Now, first step has been implemented. Now let's go for the second step. What is second step? Check whether the stack is full or not. Is my stack full? No, it is not full. So I need to push a new element in the stack. How to push the new element in the stack? Increment top by 1. So now top will be incremented by 1. Top will be incremented by 1. Then accept the value from the user. Let the value be 10, 20, 30 or any of your favorite number. Assign that particular value to A of top. So this time let the number be suppose 23. So I have assigned 23 to this particular position, right? So one element got inserted successfully. Now again we need to insert the new element. Again, if the user calls the push function, then again it will go to second number step. Again it will check whether the stack is full or not. Again this time the stack is not full. So if it is not full, then we can insert a new element in the stack, right? So but for this particular step, we will go over here. Top will be incremented by 1. So right now my top gets to position number 1. Now again accept the value from the user. So it is not always necessary that you need to accept the values from user always. You can simply push the values directly. Assign the values in the program itself, right? Instead of accepting the values from the user, you can just assign the values directly to A of top position. Getting? But to make it more generalized, I am saying that accept the values from the user every time. So this time let the value be 10. Let the value be 10. Because of this particular statement, it got assigned to that particular position where the top variable is pointing. Getting? Now again assume that again the user called the push function. So again it will go over here to the second step. It will check whether the stack is full or not. Again we found that still there is one space vacant. One vacant space is available where we can perform the push operation, right? So it will come to the third point, the third step, and what is that? If it is not full, then now you can push a new element on the top of the stack. This time again it will come over here. Top will be incremented. Now top gets incremented to position 2, right? Accept the value from the user. Let this time the element be 56. Because of this particular statement, the element got inserted at the second position, right? Now again imagine that the user called the push function. Again it will check whether the stack is full or not. But this time the stack is full. So now we need to print stack is full. So no further insertion is possible over here. Diagrammatically, if you want to explain this particular point, the push operation, if you want to explain push operation diagrammatically, how to do that, right? Suppose for example, I will just write here push 23. If this is the case, push 23. If the first operation is push 23 and you have been given the size as 3. So the stack size is 3 and the very first operation is push 23. So you need to draw it like this. You need to have a stack of size 3 every time. 0, 1, 2. And what is given? Push operation is given with the element 23. So simply write 23 over here and show the position of top. Getting? Suppose for example, the second operation is push again. This time with the element as 48. Again, as it is a part of the same example, we need to have the size as 3 only. So I will be drawing the same stack array one more time. Firstly, we have 23, so draw 23 as it is. draw the indices again one more time. Now the second operation is push, which means that the 48 will be pushed on the first position. So after inserting element on the first position, now the top variable is pointing here. Getting? Again, one more time consider that again there is one more push operation. Let this time the number be 16. So again you need to draw the same stack with size 3, right? Why size 3 always? Why? Because we have considered the size of stack as 3. Give the indices 0, 1, 2. What are the previous elements? It is 23 on the 0th position, then it was 48 on the first position. Now because of the third time push operation with the element at 16, we got inserted 16 on the second position where top variable is pointing. Getting? Again, if one more time the user calls the push function, this time let the value be 5. Now the case is that we already have the stack with all of the 3 elements inserted in it, where top is pointing to the last position. So here we cannot insert more elements in the stack. So here it will be just giving us the statement as stack overflow or stack is full. Getting, everyone? So now how do I write the code for this? So just imagine or just consider this, not imagine, but just consider this particular function. So push is the function. You need to have separate functions for all of the operations. So this push function is to be defined outside the main function and it is to be called inside the main function, right? Now I'm starting with the push function body. So what is the first thing that we need to check? Whether the stack is full or not. How to check that whether the stack is full or not? Check it with the help of top variable. So if the top variable is equal to n minus 1, then simply print that stack is full. Getting? And if stack is not full, which means that still we have some vacant positions available in the stack where we can perform the insertion operation. So how to do that? Firstly, top will be incremented by 1, so increment top by 1. How to increment top? So simply top plus plus. Then I suggest you to accept the value from the user, so you need to write the printf statement, enter the element. Getting? For entering, you need to use the scanf function. So %t, ampersand, let the variable be element. Now assign this element to the top position of the stack. Let it be labeled as a of top equal to element. Getting? I am closing the else part and now I will close the push function. So every time when we perform insertion operation, every time when we try to push a new element in the stack, firstly it will be checking whether the stack is full or not. If yes, if the stack is full, simply print that stack is full. If no, which means that there is some vacant space available, so increment top by 1, accept the value from the user and assign it to the top position. Getting, everyone? Why every time firstly we need to increment top by 1? Why? Because initially the top is assigned to -1th position. Initially we do this assignment, top is assigned to -1th position, and as it is a stack array, always the operations start from the 0th position. We do not perform any of the operation on the -1th position, right? Arrays always start from the 0th position, so always the element is to be inserted on the 0th position. But as top is pointing to -1, so firstly the very first step is that increment top by 1 and do all things later on. Getting, everyone? Now you may get a question that why cannot we have top directly to 0th position? Why always to -1th position? Yes, we can have top assigned to 0th position as well. We can have this. Only the thing is that this particular top plus plus will be switched below here. Only this will be changing by assigning top equal to 0. Only the thing is that the top will be incremented later on. Why not this sequence will be continued? Why? Because if we follow this particular sequence again, no insertion will be performed on the 0th position. It will be incremented by 1 and the very first insertion will be done at the first position. But arrays always start from 0th index, so elements should get inserted on the 0th position. So for that firstly what is to be done? Accept value from the user. Accept value from user, assign it to the position where top is pointing in the stack array, and now increment top by 1. So these will be the steps to be followed if you are taking top equal to 0. But universally top is always considered at -1th position. So do not go with top is equal to 0. It is also correct, this is also correct, but universally we do not go for top is equal to 0. We always have top initialized to -1th position only. Getting? Okay. Now let's move on towards the second operation, and that is pop operation. Okay. Now let's discuss about the pop operation, where pop means deletion. But instead of using the words as insertion and deletion, the person who invented this particular topic has given some modern names as push for insertion and pop for deletion. So now let us discuss how to pop out the elements from the stack. As I have already said that both of the operations, that is pushing and popping, push and pop, are both performed on the same end, that is from the top end, right? So now we will see how pop operation is performed on the top end. From the top end, which means that top, not considering the English meaning, the general meaning of top, but whatever position the top is pointing, to whichever position the top is pointing, that particular element gets deleted. That particular element gets removed from the stack. And wherever top is pointing, on that particular position, the element is getting pushed. This is the meaning of top end in terms of stack. So do not go with the generalized English meaning of the top, that if it is the top end, which means that everything on the top will be deleted or everything at the top only will be inserted. No. Wherever the top is pointing, on that particular location, the push and pop operations will be performed. Now let us move on towards the pop operation. So I am again considering the previous example where we are having the size of this particular stack array as 3, and as it is visible, you can see that the stack is full with 3 elements. So on the 0th position we are having the element as 23, on the first position we are having the element as 48, and on the second position we are having the element as 16, where on the last position, the second position, the top variable is pointing. Getting? Now just imagine that the user called the pop function for the very first time. User called the pop function for the very first time. Now where is our top pointing? Where is top pointing? Top is pointing to second position, which means that the element on the second position will be deleted. Now let me remind you that the meaning of deletion does not mean that we are actually going to physically delete the element from the stack. No, it is a completely logical concept. Deletion means just we are logically deleting the elements. If we actually want to delete the element from the stack, then we have to free this allocated memory. So you might be knowing the concept of malloc, alloc, right? Alloc, and the last one is free. So whatever memory is getting allocated to this particular element that should be freed when we are physically deleting the element from the stack, but we are not going in that particular concept. So this is totally a logical concept where we mean that we are deleting the element from the stack. So just assume that when we perform the pop operation for the very first time, we deleted the element from the stack. Getting? So now when the user called the pop function for the very first time, the element or the position where the top is pointing, on that particular position, whichever be the element, will be deleted from the stack, right? So now delete the element. Delete the element means what? Just print the element to be deleted. So you can just have the statement as element deleted is. Element deleted is, or element popped is, so %t, right? Printf is %t, and just write here a of top. Getting? So when we call this pop function for the very first time, it will be displaying me this particular statement as element deleted is a of top. It is 16. So this particular statement will be displayed, right? Now after deleting the element, now my top should point to the first position. And how do I get top from the second position to the first position? By decrementing it by 1. So now I will write here decrement top by 1, right? So now top, which was pointing to the second position, the element got deleted. Now it should point to first position. It got decremented and now it will be pointing to the first position. Getting? Now just assume that the user again called the pop function. So what will be the statement that will be displayed? Element deleted is, this time it is 48. Right? So let us assume that 48 got deleted, right? Now if the element got deleted from here, then there is no need to have top variable pointing to the same position. So we need to have top variable pointing to the location below that, right? And we are having 0 below that. Before 1 it is 0, right? So we need to have top over here. How we will get top over here? By decrementing it by 1. So after executing this particular statement, top gets point to 0th position. Now again assume that the user called the pop function for the third time. So again the same statement will be displayed. Element deleted is, this time it is 23. So it got deleted. Now because of the second statement, decrement top by 1, the top will be decremented by 1, and now top will be pointing to which position? To the -1th position. Right? Again consider that the user called the pop function. Now what will happen? Now? See, n was 3. We had 3 elements in the stack, but calling the pop function 3 times, we deleted all the 3 elements from the stack. And now the top is pointing to -1th position. So now this is the case that if there is no element available in the stack, and still if we are trying to pop out the element from the stack, then this particular condition is called as stack underflow. It is called as stack underflow condition. Getting? So similar to push function that during insertion we always check that whether stack is full or not. Same way in pop function, again we need to check whether the stack is empty or not this time. Getting, everyone? So if the stack is empty, then just print that stack is empty. If the stack is not empty, which means that still we are having some elements in the stack, and now we can perform the pop operation. Getting, everyone? So what should be the steps in push function? I will just write down the steps now. Now similar to push function, here there is no need to initialize the top variable to -1 again, as top is globally initialized to -1, so there is no need to again and again initialize to -1. Getting? So now what is the first step to be done? Check whether the stack is empty or not. check whether the stack is empty. Second step, if empty, if the stack is empty, then print or display stack is empty. Getting? And if not, which is to be written in the else part, if not, then display firstly this particular statement. Display the element to be popped or popped out element. Display the popped out element, right? And then decrement top by 1. That's it. So these are only the 3 steps to be followed while performing the pop operation. Let us see this through one example. Okay. So let us see example on this pop operation. So I have written the code over here. So what is the very first thing that we need to check whether the stack is empty or not. So if it is empty, which means that if the top variable is pointing to -1th position, and still if we are trying to delete the element from the stack, then it should give me the result as stack is empty. Else means that top is not pointing to -1, but it is pointing to some other location in the stack, which means that there are some elements in the stack available and that can be popped out or that can be deleted from the stack. So this one is the if condition, this one is the else condition, right? So now considering one example, so here I have considered one stack of size 3, and as you can see that the stack is full with 3 elements. So 10, 20, 30 are the elements inserted in the stack. So if it is full, so top will be obviously pointing to the second position, right? Now let us assume that the user called the pop function for the very first time. User called the function is not with parameters, so I just missed it out. So just assume that the user called the pop function for the very first time. So which element should be deleted or which element should be removed from the stack? The element or the position where the top is pointing. The position where the top is pointing, on that particular position, whichever be the element, that will be deleted first. So which is the element on the top of the stack? It is 30. So which element will be deleted? 30 will be deleted. What will be the statement printed? Element popped is 30. Element popped is 30, right? But before that it will be checking. It will be checking whether top is equal to -1. Whether top is equal to -1, whether this 2 is equal to -1, no. It is not equal to -1, so this particular condition got failed. So the control will go to the else part. And after going to the else part, what is the statement? Element popped is %t a of top. A of top, the value is 30. So it will be printing the value as 30. Element popped is 30, and then after that top minus. So this element got deleted and top got decremented by 1. Top got decremented by 1. So right now top is pointing to the very first position, right? Now again assume that the user called the pop function for the second time. The user called the pop function for the second time. Again the control will go over here. It will check whether top is equal to -1, whether this 1 is equal to -1, no. Again the condition is not satisfied, so the control will jump to the else part. And what is the first statement in the else part? It will be displaying element popped is, this time the element is 20. Getting? The second statement is top minus. So 20 got deleted and top will be decremented by 1. So now top is pointing to the 0th position. Getting, everyone? Now again let us assume that the user called the pop function for third time. The user called the pop function for the third time. Again the control will go over here to this particular if condition, right? Now what is that? Whether the top is equal to -1. What is the value of top right now? It is 0. So whether 0 is equal to -1, no. Again third time this condition got failed. So again the control will jump to the else part. And what is the very first statement over here? Element popped is, this time it is 10. So it will be printing me the value as 10. The second statement is top minus minus. So 10 got deleted and top got decremented by 1 again. After decrementing, where is the top pointing now? To the -1th position, right? Now again consider that the user called the pop function. Now this is the 4th time the user has called the pop function. Now again the control will go over here. Again the control will go over here. What is it? Whether the top is equal to -1. Substitute the values. Top is -1. So whether -1 is equal to -1? Yes. Yes. So for the 4th time when the user called pop function, this first condition got satisfied and now it will be displaying stack is